man in all of the world for right now. Hello, everyone. Welcome to another Percona live stream. I am here today with my special guest, Nickolay. Nickolay, how are you today?
I'm Matt. I'm great. Thank you.
And today we're going to make Nickolay internet famous by having him on the live stream here. So welcome to all of those out in the internet land. Hello, Jobin. Thank you for giving us a wave there. We hope that everything is working in terms of sound and video. If it isn't, just let us know and we'll make some adjustments on our side to try and fix it. So today, Nickolay is going to join us and talk to us about a topic that is really, really exciting and hot in the IT space, especially in the database space, and that is running your databases on Kubernetes. Specifically, he's going to show us how to install and use Postgres in a Kubernetes environment. But before we begin with that, I wanted to ask Nickolay, what attracted you to Kubernetes in the first place? Why did this seem like an interesting fit for you?
Well, I like the idea that something could be run in organized way, right? And if you have a single server, you can have just a few processes that will do some database job, for example. But if you want to run your application, database, maybe some mail services, journaling, and etc., you probably want to have many servers because it's too costly to find the server that will solve all needs for especially big databases. That's why we need something that should control everything on many servers, and we need something that will assume our application as a kind of process, but in multi-server environment. Kubernetes, well, it's a way that provides this thing, maybe not in a comfortable way for everyone, but at least we're able to do our job. Before, I think, last 2 years, it was hard to run databases inside Kubernetes because if you have something that can spawn and after a few seconds it can die, well, you probably worry for your data in the database. And in such ephemeral environments, well, it should be easy to lose your data, right? But if you have a good orchestration for the database, for backups, for performance metrics, probably the database also could find its home in Kubernetes. So yeah, we have operators. In Percona, we have operators for last several years. Operators is a kind of software that manages databases or manages applications inside Kubernetes. So, and for Postgres, there is a Postgres operator. It's quite young, but well, it's already useful if you want to run Postgres replication with multiple servers used for high availability. Because, well, if your server will die, well, at some moment hardware can die, or you can consider to restart server. So your database service always should be online.
Yeah, absolutely. Now, Nickolay, people are starting to use, Kubernetes for databases more often. And being in the support side, you get a lot of the people who do things maybe they shouldn't do, or maybe that they have problems with. Is there something that you're seeing people use Kubernetes in the wrong way, or doing something that's a mistake from the database perspective that you see over and over again?
I think the most interesting thing that's people thinking that the same database that's running on similar hardware, it should run in the same way in Kubernetes. Like if I have 10 terabyte database, well, why I can't put 10 terabytes database in Kubernetes? In Kubernetes environment, frequently it could be better idea to not run multiple schemas, multiple unrelated databases on the same instance. Instead, you can run multiple containers around many servers, and you will get better in many ways. You have better performance, you have better manageability because, well, backup for 10 terabytes, it's still a mess because we're limited by memory bandwidth, we're limited by flash storage speeds. It's amazingly fast, but it's still limited. So, and if backup and restore requires 1 day, well, probably it's not a good idea for such Kubernetes systems because we want to spawn another replica in, well, maybe seconds, maybe, well, hours, but not days.
Yeah. So that's good advice, right? So the shifting paradigm is with Kubernetes, you can run lots of little things as opposed to one big monolithic, and you can run them more consistently and get a more efficient way of running things in multiple. So it negates some of the need to kind of combine everything and try and minimize the number of servers if everything's running consistently across the board.
Yeah, and this is Cattle and Pat's problem because DBA are still considering database as a lovely pet. And, well, in many other companies, the database is required to do small job, store some persistent data, but not something that should be the only and a single thing in the company.
Right. Well, okay. So let us walk through. The reason you're here is to show us how to get started with the operator for Postgres. Why don't we get started? Nickolay's going to share his screen. He's going to walk us through the setup, and we'll go from there. So let me go ahead and get Nickolay squared away here. We want to make sure he is visible and his screen is visible, right? So there we go. And here we are.
Okay, so if we want to start with Kubernetes, with any application, including database, we need a cluster, right? So if you have a working kubectl command, like we can ask for nodes. So what servers we have? So in my case, kubectl command is working. If on your side it's not working, or if you're not understanding what's going on, please ask your Kubernetes administrator to fix this kubectl thing. Also can use some aliases for kubectl, so the same could be executed as get nodes. Okay, it also works in the same way, well, because it's the same command. So how to run our database in Kubernetes? Because we can run many different databases on the same server, well, on the same cluster, we need a separation logic. So we can have multiple namespaces. Let's create a new one. Create namespace PgBouncer. So like this. So, and from the start we have default namespace. Let's change the default to our new namespace.
And a namespace is a grouping of nodes, or not of nodes, of potential containers or objects, correct?
Yeah, basically Kubernetes is it's object database. As a DBA that's using databases for whole life, I say that, well, this is definitely a database with some triggers. If you're creating something, some resource, it can trigger actual changes, like it can allocate disk space if you create persistent word. So configuration, set context. I need current context, and I want namespace PgBouncer. So now I'm inside PgBouncer namespace, and it will be easy to run commands. So it's empty. If I read the list for all containers running here, there is no container. in this namespace. I want to install Percona operator, the software that will manage Postgres here. So it easily could be downloaded from GitHub. It's open source project. And actually on GitHub, we need just several files. There are some deployment examples that could be found in deploy directory. So in order to execute operator, okay, we need operator YAML. So operator YAML is, well, it's the definition for multiple resources. Some resources, well, there is some account, there are some roles, and etc. Well, this is internal. You don't need it to understand because you're going to just start the database. Let's kubectl apply this file with this simple command. And what happens here? It creates such resources that we're seeing, and we can actually check if we have any new containers in our namespace. So there is one, it tries to download images, it's already running, but well, the name is quite interesting. It's pgo deploy. So, well, this not looks like the operator. So what this thing is doing, we can do check with log, for example. Pgo. Oops. Oh, it's some script, and if you know Ansible, you will see that this format of output is definitely belongs to Ansible. So it's installing things. It's quite complex because there are many components here, right? We need to provide some security. We should create resources. Well, how operators working? I've described Kubernetes as a database that works with specific objects, with specific data, but we can create our own data. This our own data called custom resources. And well, for this data, we need like table structure. So this custom resource definition, or CRD, is a template for creating resources. And the operator will handle what happens if this resource is created. Unlike to disk allocation that we have for persistent volume, well, this thing will create pods required for our Postgres database. So maybe get pods. Okay, our deploy script is finished. The ready is 0, so it's not running anymore. But we have Postgres operator, and Postgres operator has 4 containers, and all 4 containers are running right now in ready state. So we are ready to continue. So how we can continue? We need CR, so custom resource. Well, with kind Percona PG cluster. So this is a bit version, a main or trunk version of our operator. Of course, your production, you should use a specific release. So current release is 1.1. 1.2 will be the next one. So, and this CR YAML file contains many examples. So we can specify a place where the operator will find users and passwords. There are some SSL encryption. We also should have ability to upgrade our database automatically, and we can check for new versions. So we need a database for the application because, well, of course, Postgres will create Postgres database for us, but it's a good practice to provide a database for a task. So we can, our application task, we can use PgDB. So, well, and most applications have user, so we will ask operator to create PG user. Of course, we can change it, but if we are changing it here, we also should change a secret place where we are storing both users and passwords. So, and etc., etc. Well, we need a high available installation, so we will have a primary and we will have a replica. So for the primary, it will be some specific version. For this demonstration, we will use Postgres 14. So, of course, database could consume terabytes of RAM or at least gigabytes nowadays, but for this small example, it will be enough to have just 100 megs and 1 gigabyte for storage. So the database will be used in many different ways after its installation. Of course, we can use database globally from any host in internet, but most probably your application will use the database that will be hidden inside your environment. So for us, it will be enough to create a cluster IP address. So the IP address or domain name that will be used inside this Kubernetes cluster, but not outside. Oh, and it will be automatically loaded. So, yeah, we can also enable monitoring, but let's skip it for this time. And etc. Until
so these are all the components, right, Nickolay? So all of these are the different components that could be activated if we needed them, whether it's monitoring. I saw PgBouncer there. There's different components that you can turn on and off as needed, and they'll be set up for you, saving you from having to install these and set these up yourself.
Yeah, you can even forget about existence of, for example, PgBouncer for your log parser. You can forget how to manage it and etc., but you can install it, enable it once, and it will be available for you. So,
okay,
yeah.
So, Nickolay, there's a couple quick questions.
To read how-tos. Yeah. Okay.
So the first one is from David Gonzalez, who asked specifically, I missed where the Kubernetes node is running. Is it Minikube?
Okay, probably you started a bit late, so let's check kubectl get nodes. And as you can see here, it's Google Kubernetes environment, so it's running on Google Clouds. But you can run it, of course, in other Kubernetes cluster, including Minikube. But for Minikube, there is a thing. In order to do HA, you need different servers and affinity. You need affinity. So if you will run replicas on the same server as your main Postgres, it will cause that in case of crash, you will lose both your replica and your primary. So if you want to run it inside Minikube by default, well, of course, you can try to modify it, but it runs just a single worker node in Kubernetes. So you should disable affinity checks to allow operator to run a replica.
Okay.
Yeah.
So the answer to there is we are running in GKE, and there is some work to get it done in Minikube. There's one other question here specific to the live stream, and then there's one that's more specific to Postgres. We'll address the general Postgres one in a bit. But the question from G came in, hey, what's the use case of a namespace? Why do we need to use a namespace?
There are multiple benefits from using namespace. The first is simple, that you can have different permissions. Like you can have permissions to see things but not delete or modify for database namespace for the specific user, but this user will be able to deploy application. So, well, that's great idea because the user will not be able to destroy your data. Another thing that you need some names, and if you have production and some pre-production environments, you can keep namespace separated and avoid thing that someone will destroy everything just because, well, he forgot which environment he's using. But if he's specifying, for example, kubectl, get, and pgo port, if you're always specifying the space, you will see it. But if you are not specifying, like if you're using default, you will not see this. Also, well, basically, it's a kind of idea that allows multiple people to use the same cluster, or it allows multiple environments to be executed on the same server. Like you can have development server, and each developer will have his own application and database copy, and they can share the same cluster. There is no need to create a separate cluster for each developer, especially then they're hiring or fired.
So yeah, Charlie also brought up a good point that object names in K8s are unique, but you can have multiple clusters or objects with the same name, but with different namespaces. So if you needed to name them the same. So
yeah, you maybe need to have a name like new cluster. Well, and well, every developer has own new cluster. So how you can install two applications that have a cluster named new cluster?
Okay,
several times.
Yeah. And so we were looking specifically at the different components that could be installed with the operator, and that fits into what Ninad is saying. He's asking, is it possible to deploy Patroni using this operator?
Well, actually, if you want a Postgres, and Postgres with managed replication, you definitely need some good solution. And Patroni is the best one, I think. Yeah, and actually, Patroni manages this cluster, and it's already installed.
So by default, Patroni is installed.
Yeah. It's a key component of our operator, of our Postgres clusters managed by operator. For example, we can describe our operator, Postgres, describe port. So, and describe contains, of course, a description for the cluster in text format. So, and here, I think, here, yeah. Okay, Patroni is hidden somewhere deeply, but okay, let's ignore this. But, well, Patroni is a key component here. And these replicas are managed by Patroni.
Yeah, and for all the operators really require a cluster or a replicated setup to work properly because of the nature of how Kubernetes will remove and add clusters. They're designed to be stateless, right? So containers are supposed to be able to kind of move around. So you need some sort of clustering software to ensure consistency. Okay,
let me explain this because this is actually not a requirement. If you have a Kubernetes cluster running, it's like running container. So if you stop container, you will not lose your data. So, and where the data is stored, we have persistent volume claims. So, and persistent volume claims are linked with volumes. So here there are some volumes, 1 gigabyte, as I have mentioned before. So the data will be here even if we delete the cluster. So the problem if we have node, if a node goes down, or if we are going to put it on maintenance, the pod, the containers will be killed. So with our usual servers, well, it's not happening frequently. With our Kubernetes cluster, it also could be non-frequent activity. Well, if something will die, we can, well, recreate the pod again and the database will work. But in Kubernetes world, all this thing is automated. And if we have a clustering solution, we can be online even if Kubernetes nodes are going down. So that's why we need clusters. That's why we need replication, but not because, well, it's impossible to run Postgres without any replication or cluster.
Yeah, fair enough. Fair enough. So back to the setup. So you ran the command to set up the cluster. The cluster is up and running. What about the other operations? You mentioned we got Patroni here. What about backups? What about if a failover has to happen, does automatically that take place?
Yeah, I think we should start from simple things like, okay, we started something. Can we actually use it?
Okay.
Because, okay, you saw PgUser and PgDB, but how I can connect it? So here we can run get secret and see that I haven't specified that, I need cluster 1 users, right? But this object is created automatically. Let me get secrets. So, and it's not only about PG user, there are several other users like PgBouncer, PgUser, Postgres, and etc. So we can log into the database using specific PgUser details. So how we can do it? We can create a small application like client. So I can base application on the same image, but you can create with Dockerfile your own image. So this thing will spawn a container with bash commands running in a short loop. It will echo hello and sleep for every 10 seconds. So let's apply it. Client. So after that, the application itself can do things, but in order to simplify things, I will go inside this container and run some command inside. So I can try to connect to something, but wait, what is server name? How I can use it? Okay, there is a resource that called service, or in short SVC. Both words will work. So we have multiple devices. One is our primary cluster 1. Also, we have some backup, PgBouncer as a connection pool, and replica. Replica will represent all secondaries in round robin. So let's try to connect. Echo cluster 1 and user PG user. So it asks for password. And if you remember, there are some passwords here. Like, okay, there is a password.
Nickolay, we had a question about that password. Is it possible to define the password up front?
Yeah. 1 second, I will explain it in more details. So, well, it's not working, right? I can paste the password. So, and it's not working. What happened here? So, password is incorrect. Actually, secrets in Kubernetes are usually containing base 64 passwords. Password encoded with base 64. So, and we can use echo command and run base 64 decode. And well, we will have our password and there is no line ending it. So let's copy this time correct password. So, and we can go again here. Oh, okay, we are in the right place. So, and it says that there is no database user, of course, because our database called PgDB. Oh, and now we are inside Postgres and we can run something. Well, let's create a table. And for example, C as varchar. So we have something and we can insert data. Hello. So this is definitely a database right now. What else we can do? We can connect to a replica. And it also works. And we should be able to see our new table. Yes, there is.
So we've got the replica set up now. We've got everything configured. We've shown that we can connect up. There was a couple other questions specific on the setup that I wanted to kind of get back to before we lose them. One of the questions came up: is there a minimum number of resources you need to have in order to use the operators, like CPU memory?
Yeah. Well, it's a small program written in Go. I mean, for the operator itself. If we check other stuff, we can see that there are some 4 containers in it. We can check current users. And port for the operator itself. Let's see ports. Yeah. So currently it uses a small amount of CPU. It's 12 divided by 1000 and about 50 megabytes of RAM. But this is, of course, not a database. For the database, the memory and CPU usage depends on your load pattern and on the database.
And the minimums would be the same as they would be for a normal Postgres.
Yeah. Almost the same. Of course, there are some processes, additional ones, but they're miserable compared to me.
Yeah. We also had one specifically on the authentication. Can different types of authentication methods like Scram SHA, are they supported in the operator?
Well, by default, it uses this method. We can go inside Postgres as well as we have with client. We can go to cluster 1 and some random numbers, 8 something. And we have just one container for Postgres. So if we go to the Postgres directory, It's not here. Well, probably it's mounted somewhere. So, PG data. So we are in Postgres directory. There is cluster 1, and there is PgBouncer. So this file is managed by Patroni, by operator itself. As you can see, it uses MD5. So I'm not sure if you should change it. Well, probably not. But definitely, if it's not possible to modify it with our operator, it should be a good feature request. You can go ahead, open GitHub, and fill it if you want.
Okay.
Yeah.
And so there was a question: is cloud support available for the Postgres operator? If you're talking about support for running on like either the Google or the Amazon Kubernetes services, the answer is yes.
Yeah, right now it's running in a cloud, and of course you can run it in exactly the same way in your on-premise Kubernetes cluster.
Yeah. So it is portable that way, and it can go back and forth. Okay. Continue on, Nickolay. Thank you for answering the questions as we've gone through this. This has been helpful. People interacting and asking questions as we go through. Those are good. Keep on bringing up the questions related to the operators or to Kubernetes as pop into your mind, and we'll answer them as we get a chance.
Okay, so we're able to connect, and we have a secret. And secret in base 64 format, as we can see, if we will provide YAML format for the secret. Okay, what we can do actually, if you want your own password instead of randomly generated, you can create the secrets first, and after create the password, or you can modify this secret, and it should apply appropriate changes to your database. So if you want a trick how to see it, 1 second. So here, anyway, so you can convert it to readable format relatively easily. So let me.
For those who are watching while Nickolay's getting that squared away and ready, curious if folks out there are already running some of their databases in a Kubernetes environment. Do you just want to answer in the comments as Nickolay's getting some stuff ready here?
So we can print the objects that stored inside Kubernetes in different way. For example, there is a Go template method, and you can use some code like ranges for key and values, and you can print something. So, and even code base 64 without this funky base 64 -d. So, and Kubernetes can print actual passwords without base 64 encoding for you. Like, well, okay, there is a password for our PG user. So, yeah. Why this could be useful? Normally, it's not useful for your applications, But if you're investigating what you have in your cluster, it will be definitely useful. Because for applications, it's easier to set up passwords as a secrets inside your containers. But of course, if you're running your applications outside of Kubernetes cluster, you should decode such passwords and change your application configuration accordingly.
Okay. So, Nickolay, we got a couple questions specifically on backups. What about normal operations like backups? How are they handled? How are they scheduled? Where are they stored? And how do we ensure that you can get to the backups if the cluster goes away?
So for backup, we should have some, of course, Docker image that will handle it. And current implementation uses PgBouncer. It's a well-known method to create backups, and it needs volume for this. It can use local volumes inside your Kubernetes cluster, or it can also use volume outside. So
when you say outside, like an S3 bucket?
Yeah, exactly, in some object storage, because backups are really huge, and storage as SSDs, well, it's costly to store your backups on SSDs instead of storing it in something like Amazon Glacier. So, and in order to do the backup, we should do several things. We should specify, we should create a task. These tasks should create a backup for specific Postgres cluster. Well, it could be an incremental, or it could be a full backup. So, and we can store it. So let's try to run it.
Now, Nickolay, with that backup script, or the backup YAML, when backups are being deployed, is it automatically scheduled to run when the operator creates the database, or do people have to schedule it or figure out how to set that up after the fact?
Well, PgBouncer has multiple ways to do backups. It allows to do point-in-time recovery. And point-in-time recovery is, it uses write-ahead logs directly from Postgres. So that's why the backups automatically configured. And if you remember, we had this PgBouncer cluster 1 pod, shared wrapper thing running for a while. So this container is used to store all these write-ahead logs and backups. Yeah, you see, and we also have this, persistent disks dedicated for backups.
So there's a pod that's running the backups, and then there's a pod, or there's disks, persistent disk for those backups. If you're running local, if it's on S3, then obviously it's going to go out to the cloud or wherever you're storing it. And that's automatically, when you start it up, it'll start running on the default settings, but you can change those default settings if you need to, is what I'm hearing.
Yeah, and you can run your full backups to be able to restore things faster.
Okay, and so from a backup perspective, is that going to run off of one of the replicas, or is that going to run on your primary? Well,
let's go and check what's going on, because we have executed backup, and it created a new container, and this container is already finished. But the thing that you should love Kubernetes for is the ability to see logs for already finished tasks. So as you can see, okay, it runs PgBouncer, and there are some traces for crunchy data operator, because Percona operator was started as a fork of crunchy data operator. So, and it executes PgBouncer rest. On DB, it has IP address ending with 4. So we can get a list of containers with IP addresses. And this .4 is actually related to our main Postgres. So it's executed against primary server.
Okay. Is there a way to change that to the replica? Oftentimes, you don't want to take your backups directly against the primary.
Well, I'm not sure how it's implemented currently, but definitely this could change in future as well.
Okay. There might be something that we want to float up.
Yeah. It's not only depends on our operator. It also depends on how PgBouncer rest works. Yeah, because in Percona, we are using open source components. We like open source. And even for backups, it's not some custom solution. It's properly configured PgBouncer rest.
Okay. And I think, did anybody else have any questions specifically on backups? I think we covered all of them that were asked. I don't see any more questions. Continue on, Nickolay.
Okay, but we also maybe want a restore. I'm not going to show restore right now, but well, at least for restore we need to delete cluster, delete things. So I don't want to do it right now, but restore, what you can do, you can restore from specific cluster, and you can restore to specific cluster. So it restores from cluster 1. Storage type 6 means that we made the backup on disk, not in a cloud, and we can use point-in-time recovery to specify a date and time, and the backup will not do forward after this point. Yep.
All right. So Charlie wants to know about splitting load. PgBouncer setup or HA proxy.
Yeah. For the load splits, first of all, in Postgres world, Postgres uses multiple processes model because, well, it's safe model. It allows specific backend to die without problems, and whole database continues to work. So, but it's not a good solution for applications that's connecting and disconnecting frequently. That's why we need some connection pool. And here for this operator port, if we check get port again, you can pay attention that there are several PgBouncer containers. And also for secret, there is a PgBouncer user. So PgBouncer is somehow integrated here. So we can go to our webinar. We can go to our client and execute some select commands. So we can connect to PgBouncer. Not this, but I need client. Yeah. So instead of connecting to replica, we can go to PgBouncer. So cluster 1 PgBouncer. Of course, we need again the password, but it was close here, not PgBouncer, but this PgUser. So, and now we're connecting with PgBouncer. And from application side, it's not making significant changes. We still can select from T, right? Well, probably from T. Yeah, it works. So, but what is the difference? The difference is we can get the IP address for the server. It will show that it's a primary. So, and even if we are connecting several times, this IP address will not change. So, as you can remember from our backup investigation, it's our primary. So, PgBouncers, even if we have 3 of them, they're connected to the same primary. So, why we need such strange setup? Because, well, allocate 3 servers just to do the same job, right? This looks stupid, maybe. But the Kubernetes is all about running things in a cluster, running things highly available. So even if any of these PgBouncer things will be dead, the service name service name cluster1 PgBouncer, the thing that I've used to connect with Pisco, it will route to a live PgBouncer pod. And this live PgBouncer will be able to connect to our primary. So yeah, this works in this way. About splitting the load, well, if we have multiple replicas, we can run some select queries on it as well. So, okay, how it works? It's not using PgBouncer, but we can specify a replica here. And of course, it's asking for a password. And I'm not sure if the password is in Clipboard, but let's check. Okay, of course. Okay, let's return back. So PG user. So we are connected to replica, and we can repeat the query. The IP address is changed. So if we will repeat this query, it will always provide same IP address. But if we connect several times, you can see it's a different IP address. Yeah. So what this means, if we return back to services, there are services with cluster IP type. And cluster IP type means that we can access this specific IP address. But instead, our request, instead of going to this IP address, will go to specific port of a different server. And how this is described, there are things that called endpoints. So, and each service is linked with specific endpoint. For example, here, PgBouncer is linked with this, and PgReplica with that.
Yeah. So, Nickolay, we had one other question outside of PgBouncer here. It's about replication and how to replicate to nodes outside of Kubernetes.
So in order to replicate outside, we should export our IP address, right? Because here, if we get service, here you can see that, there is no public IP address. There is no external IP address. But what we can do, we can go to the, not here, but I think here there is an example. Let's open read only. So there is an example how to do things, how to export your server. You can create a service with type load balancer. And the meaning of this load balancer depends on your cluster provider. For public clouds, this will automatically allocate some public IP address or IP address from the network you have specified for your VPC, if we will talk in Amazon terms. So you can specify load balancer and you will get IP address that will be addressable over internet or over your internal network, but not on the inside. So, and you will be able to use it as a connection point for your streaming application.
Okay. Okay. So I don't see any other questions. There was one earlier that was specific to not the operator, but for Postgres. And we can probably just see if we can quickly address that. And it was someone running in RDS, 2 instances in the same VPC, same region. They're using logical replication. And one of the databases is 1.2 terabytes, or the database is 1.2 terabytes, but the replication is going very slow, like 1 gig for 5 hours. That seems like it's a configuration issue if the replication stream is that slow. Nickolay, any thoughts on that?
Well, if it's the same location, so the network should be fast, right?
Yeah.
So it could be something that prevents Postgres from processes in a reasonable speed. So, well, it's hard to say what's going on right now just with those symptoms, but, well, definitely, you can try physical replication because it will need less decode power. And you can also check what's going on with your application because it's, you can run some short, simple queries. And if those queries will modify billion of rows, well, this could create such delay easily.
Yeah.
So instead of using such big transactions, you can consider to change your application to, for example, delete just 10,000 rows at once to reduce delay for the replication process.
Yeah, so the short answer is there needs to be some investigation to figure that one out. That's not a easy one to just answer.
Definitely.
So Nickolay, thank you for coming out and showing us, how the operator works, giving us some insight, walking us through some of the common commands, and definitely thank you for answering some of the questions here. If you like this out there who are watching this either live or in the future, go ahead and subscribe, hit the like button. Let us know if there are topics you want us to cover. We would love to hear from you. We want to do things that are meaningful to the community, and so if there is another topic, if you want to see this for MySQL or for MongoDB, feel free to bring that up. In fact, in another week, we're going to have Sergey Pronin going to be walking us through the MongoDB operator. So we're going to have a similar discussion around that as well. So thank you all for coming. We appreciate your time here, and we'll see you next time.
Yeah, don't forget that Postgres and Kubernetes is just starting from such topics. And we are ready to provide significantly more interesting stuff to do, right?
Yes, absolutely. All right.